Hello, Algebra 1. Today we are going to talk about the third method for solving a system of equations. So remember, anytime we solve a system, we're looking for a point on the graph where two graphs or two lines, in our case right now, intersect. So the third method, we've talked about graphing, we've talked about substitution. Our third method is called elimination. It's going to consist of adding two equations together to eliminate either the x or the y value. Okay, so we can't solve these equations that have both x's and y's in them, so we have to get rid of one. So to eliminate a variable, the coefficients of the variable must be the same number but different signs. So if one of them I have a 2x, and if in the other function I have a 3x, I have to figure out how to get rid of these. So the first number they have in common, so our least common multiple, so that's when we're counting by this number. So 2, 4, 6, 3, 6 is going to be 6. So in order to get 6 here, I have to multiply times 3. And in order to get 6 here, I have to multiply times 2. But I also have to remember that I need a 6 minus a 6 to equal 0. So either one of these has to be a negative, so that at least one of these, when I multiply it out, comes up as a negative 6x, and I can get a 0. Okay? So that's what we're talking about when we're talking about it must be the same number, but different signs. So the number here is 6. One of them's positive and one of them's negative, though. So let's take a look at this first one. So for this first one, we have negative 4x plus 7y equals 30, and 5x minus 7y equals negative 34. Very first thing I'm going to see is if I can cancel anything without having to multiply. So if I look here, I have a positive 7y and a negative 7y. So when I add these two linear functions or these linear equations together, that's going to add up to 0. So now I'm going to go on ahead and I have to add all my terms together. So negative 4 and 5 is 1x. 7 minus 7y is 0. And 30 minus 34 is negative 4. So that's x equals negative 4. So now, just like in the past, I have to choose one of these equations and I have to plug x back in to find my y. So 5 times negative 4 minus 7y equals negative 34. 5 times negative 4 is negative 20. Minus 7y equals negative 34. Add 20 to both sides. I get negative 7y equals negative 14. Divide by negative 7 and I get y equals 2. So my coordinate where these two graphs will touch is negative 4, 2. So that one was easy. We didn't have to do anything to it. These automatically canceled. But what happens if we can't eliminate a variable just by looking at it? So this is where we have to start multiplying things. And sometimes you have to multiply both, like I did here. Sometimes you only have to multiply one. It just depends on what the values are. So I have 4x plus 3y equals 19, and 7x minus 6y equals negative 23. Now, you can choose to get rid of either the x or the y. It doesn't matter. What I'm going to look at is I'm going to look to see which one would be easier and which one I would only have to multiply one of the equations by, hopefully. It doesn't always work out that way, but sometimes it does. Okay, so the first thing I'm going to see, I have a 4x and a 7x. So my least common multiple there, if I count by 4s, and then if I count by 7s, is 28. Okay, so I'm going to have to multiply both of these equations by something in that case. So let's go on ahead and take a look at our y. So we have 3y and 6y. So my least common multiple, if I count by 3s, is 3, 6. And counting by 6s is 6. So if I want this 3y to be a 6, I have to multiply it by 2. But that means that I have to multiply every single term by 2. And then I have to decide, do I want it to be a positive 6 or a negative 6? Well, if this one's a negative 6, then this one needs to be a positive 6, so they'll cancel out. So now I'm just going to multiply this out and write it. So 2 times 4x is 8x. 2 times 3y is 6y equals 2 times 19, which is 38. This one I didn't change, so I'm just going to rewrite it. 7x minus 6y equals negative 23. And now I'm going to add these two equations together. 8x plus 7x is 15x. Positive 6y and negative 6y is 0. Those should cancel, or I've done something incorrectly. And then 38 minus 23 is 15. Now I'm going to divide both sides by 15, and I get x equals 1. And so now I found my x value. Now I need to go back and I need to find my y value. So once I've solved for one variable, how do I always solve for the other? I plug it back into either equation. So I'm just going to choose the top one this time. So 4 times my x value, which is 1, plus 3y equals 19. So that gives me 4 plus 3y equals 19. Take away 4 from both sides, and I get 0 there. So I get 3y equals 15. Divide both sides by 3, and I get y equals 5. So my coordinate, or my point where these two graphs will touch, is the point where x equals 1 and y equals 5. Okay, let's go ahead and take a look at another one. So this next one says 2x minus 3y equals 20, and 11x plus 2y equals negative 1. I'm going to start the same way. So 2 and 11. Well, the first number both of those go into is 22. So I would have to multiply this by 11 and this times 2. Negative 3 and 2. So the numbers 3 and 2, the first number they go into is 6. So either way, I would have to multiply both of these. But I'm just, and it doesn't matter, once again, which one you choose. I'm just going to choose to get my y's to cancel, just because I have to multiply by a smaller number. Okay, it doesn't matter which one you do though. So I need this 3 to be a 6, so I need to multiply by 2. I need this 2 to be a 6. So I have to multiply that whole thing by 3. And I need to check my sign. So this would be a negative 6. And this is going to be a positive 6. So I don't need to change the sign, either of the signs there. So now I'm going to multiply these out and rewrite them. So that's going to be 4x minus 6y equals 40. 3 times 11 is 33x plus 6y equals negative 3. And now I'm going to go on ahead and I'm going to combine my like terms. So 4 plus 33 is 37. Okay, so 37x. And 4 take away, so negative 6 plus 6 cancels. And 4 take away 3 is 37. Divide both sides by 37. And I get x equals 1. Now I need to plug this x back into either one of these, okay, original equations, to find my y value. So 2 times 1 minus 3y equals 20. And really, just so you know, you could plug it into one of these also. But if you made a mistake here somewhere, then it's more likely that you're going to get a right answer that shouldn't be right. So I would always go back to the original. So 2 minus 3y equals 20. Subtract 2 from both sides, and I get negative 3y equals 18, and divide by negative 3. So y equals negative 6. So my coordinate is going to be 1, negative 6. Let's go ahead and look at a couple of word problems. So this first one says the sum of two numbers is 28 and their difference is 6. So we have two numbers. We don't know what those two numbers are. So what should we call them? Well, we should call them x and y. So the sum, adding them together, is 28. And the difference of those two numbers, so x minus y, is 6. So now we're going to go on ahead and solve this. So I can see if I need to multiply by anything. Well, in this case, my plus and minus y will cancel. So I'll be left with 2x equals 28 plus 6, which is 34. Divide by 2, and I get x equals 17. So now I can solve this by saying 17 plus y equals 28. Subtract 17 from both sides. And I get y equals, let's see, 11. So I don't need to write this one as a coordinate because it's a number, it's a word problem. So it's just saying, hey, you know, how much or what number is this and what number is this? Okay. So this next one says 3 pairs of jeans and 6 shirts. So 3 pairs of jeans. So that's going to be 3 pairs of jeans and 6 shirts is, we forgot the is there, $104.25. It says the cost of 4 jeans and 5 shirts is $112.15. So now I need to solve this. So I'm going to go on ahead and do it just like normal. So my 3 and my 4, my least common multiple counting by 3s and counting by 4s is 12. And 6 and 5, I count by 5s and I count by 6s, I get to 30. It's the first time they both have the same thing. So I'm going to go on ahead and cancel my jeans. I need 12 here, so that means I need to multiply by 4. I need 12 here, so that means I need to multiply by 3. These are both positive, which means either one of these numbers needs to be negative. So I'm just going to go on ahead and make that second one a negative. So now I'm going to go on ahead and write it out. So I have 12 jeans plus 6 times 4 is 24 shirts equals 104.25 times 4 is $417. So now let's go on ahead and do the next one. So I have negative 12J. And then 5 times negative 3 is negative 15 shirts. And 112.15 times negative 3 is negative 336.45. Now I can combine those and I can figure out my costs. Okay, so my 12 and my negative 12 cancel. 24 take away 15 is 9. So I have 9 shirts and 9 shirts equals 417 minus 336.45, $80.55. So that means that one shirt is $8.95. So now I need to go on ahead and I need to find my cost of my jeans. So I'm just going to choose either one of these original equations. So 3 times my jeans plus 6 shirts at $8.95 each equals that 104.25. So 3J plus 6 times $8.95, $53.70 equals 104.25. Subtract 53.70 from both sides. And I get 3 pairs of jeans equals $50.55 divided by 3 gives me $16.85. So 1 pair of jeans is $16.85. We're almost done with 4.3. We have a couple more problems to try and a couple more things to talk about. So let's go on ahead and try this next one. So this next one, I have 5x minus 3y equals negative 36 and 2x plus 3y equals 15. So my y values are the same and they have opposite signs, so I don't even have to multiply either of these. So 5x's plus 2x's, we're always adding these two, is 7x's. Negative 36 plus 15 is negative 21. So divide both sides by 7 and I get x equals negative 3. That's my x value. Now to find my y value, I'm going to plug x back in. So 2 times that negative 3 plus 3y equals 15. I chose the second one to plug it into. Negative 6 plus 3y equals 15. Add 6 to both sides and I get 3y equals 21. Divided by 3, so y equals positive 7. So my answer is negative 3, 7. And remember, it's a coordinate. All right, let's go on ahead and take a look at another example here. So I'm going to go on ahead and do my y's just because they look like they'd be the easier one to do. Doesn't really matter, remember, which one I do first, if I get rid of x's or y's. So if I'm going to get rid of my y's, and another reason I chose my y's is because one of them is already negative. Okay? It doesn't matter. Once again, you can get rid of x's. So 2 and 5, the least common multiple, the first number they both go into is 10. That means I need to multiply 2 times 5, and I need to multiply 5 times 2. So that's going to give me a 15x plus 10y equals negative 5. If I multiply this 2 times every single term, that's going to give me an 8x minus 10y equals negative 64. Those 10s are going to cancel. 15 plus 8 is 23. So I have 23 x's equals negative 64 minus 5 is negative 69. And then I need to divide both sides by 23. And I get x equals negative 3. Now let's go on ahead and plug that x back in to find our y value. So we have 3 times negative 3 plus 2y equals negative 1. So negative 9 plus 2y equals negative 1. Add 9 to both sides. 2y equals 8. And divide, I get y equals 4. So my coordinate then is negative 3, 4. So when we talked about solving by graphing and substitution, we talked about lines that do not intersect, that are parallel. So this type of system is called inconsistent, and our solution is no solution. So that would be where when we're trying to solve this up here, we get 3 equals 4, or we get 2x equals 3x, okay, as long as x is not 0. Okay, as long as x is not 0, those are never going to be the same, and 3 will never equal 4. When 2 lines do intersect, it's called consistent. So remember that it's independent if it touches on one solution, like the ones we just did. And it's dependent if our solution has infinitely many solutions, if it's the same line. And that's where we will get a 3 equals a 3, or a 3x equals a 3x, okay, where both sides of the equal sign are the same while we're trying to solve it. And so let's take a look at a couple of these problems in action and classify them. Okay. So 7x minus 12y equals negative 22, and 5x minus 8y equals negative 14. So 7 and 5, the first number they both go into is 35. 12 and 8, the first number they both go into is 24. So it doesn't matter, I can choose either one. I'm going to go on ahead and choose my x's just because. So I have to get 7 times something to equal 35. So that's going to be 7 times 5. And 5 times 7 equals 35. Now these both have the same sign, so I need to change the sign on one of them. It doesn't matter which one. So that's going to be negative 35x plus 12 times 5, which is 60y. And 22 times 5 is 110, and that's a negative and a negative, so that's going to equal positive 110. And let's go ahead and do the bottom one. So 7 times 5x is 35x. 7 times negative 8 is negative 56y. And 7 times negative 14 is negative 98. Now I can go on ahead and I can add these together. So those are going to cancel. 60 minus 56 is 4y. And 110 minus 98 is 12. Divide both sides by 4, and I get y equals 3. Now I can plug that y back in to find my x value. So 5x minus 8 times 3 equals negative 14. So that's 5x minus 24 equals negative 14. Add 24 to both sides. And I get 5x equals 10. Divide by 5 and x equals 2. So my coordinate is 2, 3. Okay, so to classify this system, it's consistent because it does have a solution and it only has one solution, so it's independent. Let's go on ahead and try this next one. So I have negative 7x plus y equals negative 2 and negative 7x plus y equals 5. So to me, it looks like getting rid of the y's would be easier because I just need to multiply one of these times a negative number. Okay, so if I multiply the bottom one times negative 1, that gives me, on the top stays the same, so negative 7x plus y equals negative 2. And our bottom equation becomes positive 7x, because a negative times a negative, minus y equals negative 5. So now I'm going to go on ahead and add these. Negative 7 plus 7 is 0. Positive y minus y is 0. And that equals negative 7. So here I have 0 equals negative 7. So that means that there is no solution. Okay, so that's our answer. And it means that these things are inconsistent. All right, so that is all for elimination. Practice it and ask questions if you have any. Have a great day.